In part 2 of optimizing RayTK performance, we'll discuss which operators are costly and what alternatives are available. If you haven't already watched the first part, I recommend starting there before watching this one. That said, let's get started. First, we'll discuss operators that repeat the work of their input multiple times. These are similar to the work multipliers that we covered in part 1, but specific to individual operators in the definition of a scene rather than kind of at the whole scene renderer level. And while that might sound like that means that these have less impact, that isn't actually the case. So recall from part 1 how the work for everything upstream of the SDF in your network is being repeated many, many times for each pixel. So if anything in there is expensive or is repeating a lot of work, then that effect is going to be magnified by the number of times that the renderer has to run it. The instance operator is a good example for this sort of duplication work. Instancing in RayTK is different than traditional geometry instancing in TouchDesigner. So let's first look at kind of traditional instancing in TouchDesigner. With traditional instancing, it's much better to use instancing rather than duplicating geometry in SOPs with something like a copy SOP. So if we switch over to something like this, where we are creating multiple copies of it within the SOP world, and then passing that over to the geometry comp for render, that's going to be much more expensive than just having a single unit and then having the GPU create a large number of instances of it within the render. So we can crank that up fairly high. So, this is just 80 of these, but we can easily go to, 500, 800, and so on. And that does have a little bit of an impact on performance, as you can see, but it's nowhere near what that impact would be if you were doing that all with copy SOP. So we can also use tops to pass coordinates in for instancing and other properties. And with tops, those numbers can get really big. So in this case, those are the kind of the little yellow bits in there. We have 262,144 instances of it. And that's just with a 512 by 512 texture. And we can bump that up to like 1024 by 1024. So now we're talking about millions of instances, and it's still chugging along at 60 frames a second. But in RayTK, in a sense, that kind of GPU magic that enables that really efficient duplication is sort of already being used by the number of repeated steps that are involved in just ray marching in general. So you can't really stack magic on top of magic in that sense. That's an oversimplification, but general concept is valid. So let's take a look at instancing in RayTK. So we've got an operator called instance, which seems to kind of work similar to geometry instancing that we had been using up in the kind of SOP geometry world. And we're giving it a chop with a bunch of positions, and it's creating those in a ray marched render scene. When the instance operator is used on an SDF, that means that when the renderer is asking it about a point in space, as it does many times per pixel, it will ask about that point, and then the instance operator will repeat the work of its input, in this case the sphere SDF, and it will do it once, and then it will do it again, and it will combine the results, and then it will do it again and combine the results, and so on. So There are some nice benefits to that where we can do things like smooth blending between the instances and they can overlap each other. And there's lots of niceties to being able to repeat all of that work, but you do end up paying for it. So in this case, we're only looking at 80 here. And even that is high for what I typically use. Now, it's worth noting that with the instance operator, the length of the chop that you pass it is not what determines how many instances there are. It has a parameter for instance count, and that number is kind of baked into the shader in a way, so changing that is going to cause a lot of performance loss while the shader recompiles. And it will just kind of use the first however many samples from whatever chop you give it. So here, we've got 500 samples. We're only really using the first 80 of them. So let's try bumping that up a bit more to like 200. Right, which is well below what we were doing with chops in the kind of standard render world. But look what just happened to our frame rate. So we just dropped to, 15 to 19 frames a second. And that is going to be a problem. And that's in this case, Sphere SDF is literally the cheapest possible SDF. So anything that's more expensive than that, this is just not a viable option. So you kind of need to rethink instancing approaches with RayTK and kind of focus on smaller numbers of them, but interacting in more interesting ways or something like that, rather than relying on large numbers or even reasonably large numbers. So when you're using instancing in RayTK, so you'd want to, 10 to 30 instances is fine usually, just depending on complexity, but 500 or even 200 in this case is way too much. And there are still some approaches that you can take if you really need that and you're okay with non-real-time rendering, but that's kind of a separate topic. The next few operators that we're going to discuss are similar to the instance operator, where they duplicate their input multiple times. First of these we're going to talk about is linear clone. So the linear clone operator is basically just an instance operator that includes some features for arranging the instances in a line. So again, that means that in this case, we are doing 4 times the work of everything that's upstream from that. It has some benefits. You can have them overlap each other as much as you want. You can do things like smooth blending between them. And you get kind of the full shape for each of the things, and they can kind of interact with each other and have no limitations on them like that. Now, for a simple SDF, that might be okay. And I've on a lot of these, I've switched on anti-aliasing just as a way to kind of magnify the impact of the problems. So you may be able to get more reasonable results, even if you have, more than 4 or whatever, how many clones you've got. So I'm just going to go back to the anti-alias 4. The Modulo 1D operator is an alternative to linear clone that's much cheaper. So to understand exactly why, I recommend watching the repetition filters video from the intro series. But general idea is that it slices up space along one axis and kind of creates echoes or reflections of whatever was in that original area. And it arranges them out along each of those slices. Now, the main limitation of this operator is that things can't cross over the boundary between the cells. And when they do, you get some kind of nasty render glitches where the renderer can't really figure out if there is or isn't a surface there. But if the shape that you're working with is small enough, then that doesn't really matter. In order to use Modulo 1D in a way that is equivalent to what linear clone does, we are using this limiting feature where it basically stops slicing up space after some number of slices on either side of that center slice. In order to get Modulo 1D to behave similar to the linear clone, we're using a feature here called limiting, where it basically stops slicing after some number of slices on either side of that center. Now, one of the big advantages of this operator over linear clone is that the limit is optional, so you can switch that off, and no matter how far you go in either direction, it will continue repeating infinitely. Next up is grid clone, which is similar to linear clone, but instead of just doing a single row, it does it in a grid along 2 or even 3 axes. Now for 2D, it's basically just setting one of the axes to have a count of 1. So here we only have 1 along the z-axis. Similar to with linear clone, these shapes here can overlap each other, they can interact, you can even blend them together if you want. But this is going to have a significant performance impact, especially if we bump up anti-aliasing to 3 just for demonstration purposes. A little bit of a side note here, this pattern where it's kind of starting at 1 frame rate and then intermittently dipping down to a slower rate and back up again. This is one of the ways that RayTK performance issues, when they're particularly bad, can manifest. I do not know why it does this instead of just kind of constantly being low or in the middle or something, but if you see this in a graph of frame rate or you notice it dipping down, then that means you probably have a performance issue. So now going back to the grid, for 2D, in this first case, we have a cheaper alternative called Modulo 2D. And notice how much more efficient that is. We're capping out at 60 frames a second, even with an anti-aliasing of 3. This is similar to Modulo 1D that we already covered in the previous section, but just along 2 axes instead of 1. It has similar limiting options to Modulo 1D, where you can control how many slices it does before it stops slicing, or you can have it be infinite along both of those axes. For a 3D case, let's look at this one here, where the performance for grid clone, say 3x3x3 grid, is so bad that I'm actually going to decrease the anti-aliasing just to get it into a vaguely usable range. The reason for that is that it is repeating the work of everything upstream of it 3 times times 3 times times 3 times, so 27 times. And that adds up really quick. Similar to with the other 2D variant, we have a cheaper alternative though, Modulo 3D. So switching over to that, and we're back at basically 60. This operator, again, it has options for limiting how many slices there are, and you can have it be infinite on all of the axes. One thing to note there, though, is that when you have something infinitely repeating along all three axes, there's a pretty high chance that it's going to intersect the camera at some point, which will block your view. But there are ways to work around that. And similar to the Modulo 2D and 1D for that matter, there are limitations here with not being able to cross over the barriers of each cell in the grid. And renders getting kind of messed up where things get cut off partway. Next up is Radial clone. Radial clone is similar to linear clone, but just with rotation instead of translation along a line. Note how we've got 4 copies of the shape, and they can cross over each other. We can blend them with each other if we want, but it does mean that we are doing 4 times as much work for everything that's upstream. Similar to the other operators, there is a cheaper alternative called Modulo Polar. So let's switch over to that. Now that is significantly cheaper, but things can't cross over those boundaries sliced out around that axis. And just if we go up to like 6 or something, you can see where that is getting cut off there. And if you do some kind of rotation on that is asymmetric, then things get real glitchy where the shapes get cut off. To sum it up, here are the available repetition operators. Lots of them are really cheap, including a bunch of the more unusual ones, but the various clone operators and instance and a few other more unusual operators can be really expensive because they involve doing work potentially many times more than it would with one of the cheaper alternatives. So this information is also on the documentation site, and I'll put a link in the video description to that. That's it for the repeater operators. And there are some additional ones that are just expensive on their own, even without any duplication involved. I'm just going to go over a few of the really common ones, but there may be others. It's worth noting that there is at least some possibility for some of these cases that the performance is going to be improved in later versions of the toolkit, but for some of them, it's not going to get any better than it is. The first example that we're going to look at is the head SDF. The head SDF is an amazing element to use in scenes. It was made by T.D. Hooper on Shader Toy by carefully positioning tons and tons of different small SDFs and blending them together in just the right way to get them to somehow make a human head. So to get a sense of what that's like, let's look at the code for that operator. So still going, still going, still going. All of this is happening just to make that one head. Still going. And so on, and that's it. So there is a lot of complexity in there. And no matter what else you do to optimize a scene, if you have a head SDF in there, it will have a performance cost. Now you can try to kind of reduce the number of times that you're paying that cost by avoiding the work multipliers that we discussed in the first part, or the repetition operators that we discussed earlier here. But the operator is simply expensive. Just for reference, let's look at the box frame SDF as a comparison. And that is all the code for box frame. So compare that to what we had for the head, and you'll get a sense of why the head is expensive. Next up are noise-based fields. For noise-based fields, basically all of them are at least somewhat expensive, though in general, the noise field operator itself is somewhat costly, but not nearly as bad as some of the others. And the different modes that you have selected here will have different performance, including this cheap random lookup one, which is like really, really cheap, but extremely limited. But in general, they're costly, but not extreme. One that is just extreme because that's what it is curl noise. So let's switch over to curl noise, and that is what happens to our frame rate. We are hitting about 7 FPS. This operator just involves a lot of computation, and there isn't really much that can be done about that aside from using it sparingly. So let's look at some of the other ones. So wavelet noise field, let's swap that in. We're definitely seeing a loss there. We're getting down to like 33 frames a second, but it is not nearly as bad as curl noise. But even still, this could be problematic depending on what else is going on in your scene. So looking at something like whirly noise field, then this one's actually pretty cheap. So this could be a cheap alternative, kind of similar to this regular noise field over using one of these more costly ones. Another one that's kind of noise-ish is the cell tile field, which is really quite cheap. So that gives you kind of noise-like patterns, sort of a Voronoi type of pattern, without the kind of extreme costs that you get with curl noise or wavelet noise to some extent. That is it for this section. The general idea here, as in the previous section, is to use the simplest, most limited options that still do what you want them to do. So for example, if you are repeating things in a ring and you don't need them to overlap, use Modulo Polar instead of Radial Clone and you will save a lot. But if you do need that kind of overlapping or blending or something, then you just need to be aware of that cost. And for the expensive ops, the ones that we went over a couple of them there, but for any operator, an SDF or field or something that you're adding in, just kind of watch your frame rate as you're adding things into the scene. You're going to see a dip when you're connecting things. We'll talk about that in the next section. But if you keep an eye on frame rate, you should be able to kind of get a sense of which operators are going to be costly just on their own. In the next section, we are going to discuss some ways to optimize individual operators using parameters, as well as getting into a little bit about how parameters work in RayTK in general. Thanks for watching, and as always, make sure to like and subscribe.